Have you ever made one of those "that's it" resolutions? Like, that's it, I'm not eating fast food anymore. That's it, I'm working out every day this week. Or obviously, you can see my struggles as of late. So I'm gonna have a "that's it" moment of this series because there's so much stuff that we could talk about with AWS. We have to bring it in. I'm gonna say that's it. We're gonna spend the rest of this series breaking down AWS services. And we're gonna start with what I would call the biggest one of them all, which is EC2. Now, this was not the first AWS service that was created. However, it's now become the most popular and kind of the hub of all the other services. They all focus in on what can we provide to the EC2 components. So we're going to look at what EC2 is all about, look at some of the terminology that can be used when you generate a virtual machine in the cloud, because if you don't know them, sometimes it gets a little confusing. And then finally, we'll break down EC2 instance types, as in how big of a server can you put in the cloud. Well, let's start off with what is EC2. Well, what it stands for is Elastic Compute Cloud. I know, two C's, C2, get it? Pretty witty. It is a pay-per-use scalable platform to launch virtual servers, and I'll say based off of the Linux and Windows operating systems. So let me jump over there and show you what I'm talking about. This is the management console, the main page for Amazon Web Services, and right over here is EC2, virtual servers in the clouds. Now you can see that in my cloud, or at least in North California. Remember, these are the regions that AWS allows you to create servers in, and inside of each one of those regions is 2 or more availability zones. But in this region, North Carolina, California, I have 0 running instances. So if I wanted to see, I could come over here to my instances, and I would see that I have 1 instance here, and that is an Ubuntu email server that I created some time ago, but it's stopped. It's not running. So I don't have any active servers in this cloud, but if I wanted to, I could start launching instances. And this is where, remember some of the terminology. Instance is a virtual machine. I'll break down the terminology in a second. But down here I have all the controls of features of Amazon related specifically to AWS. So we'll come back to those in just a second. One of the, I would say, first terms you'll want to catch is that all these servers are built from AMI, Amazon Machine Image Templates. What's that mean? It means normally when you build a server, you put in a DVD or CD-ROM, right, and you boot up and install an operating system and all that. Well, in the Amazon world, they've actually pre-created a lot of pre-built systems for you. Now, they are all well, I shouldn't say all. Many of them are base install images, so it just saves you the time. You know, for instance, instead of putting in a DVD and installing Windows, going next, finish, waiting an hour for it to finish and all that, you've already got a pre-configured Windows system there. Let me actually show you. I'm going to come over here and I'll say, let me launch an instance. It comes up into this launch wizard. How do you want to launch it? I'll talk again. I'll break all of these down. I've got a very practical nugget I'm going to get into in a couple. I think either the next one or the one after that. I'll really break down how we do each one of these things. But I'll use the classic one, and right here are the quick start, as in the most common templates that people use. Now, right up front, you see Amazon Linux AMI. This is a custom Amazon build that, sorry, I should say custom Linux build that Amazon created. Shows what it all includes on there, but I could go down this list: Ubuntu servers, cluster compute, Amazon Linux, Red Hat Enterprise Linux, which actually, I know probably by now it's not, but it's a brand new free operating system. I shouldn't say a let me back up. It is a now available to the free tier of service. You know, all the images that you can run for free. That's now one of them. And you can see Windows servers R2 base. So let's just, I could read all these to you, but I'm not going to. Let's just say I wanted to run Windows Server 2008 R2 base. I'll select that guy. It says, well, how many instances? What kind of instance do you want to create? Continue, next, and launch. I know, you're like, whoa, but wait, huh? What? Yeah, so there was a lot that I just went by, and I'm not going to break that down right now at this very moment, but that gives us an instant Windows server in the cloud. Now, it's going to take a little minute while it builds, and that's going to copy over all of the volume information, but I would say, let's see, maybe 8 minutes, 7 minutes. And 33 seconds. This thing will be done building. I'll just be able to click the power button and poof, I have this immediate Windows server in the cloud. Now, again, I mentioned the practicalities are coming. Whoa! Did you see that? I said 7.5 minutes and bam, it's run. Well, okay, hang on. Status check. Okay, we're initialized. Okay, I thought that's it. No way. So essentially, what it was doing is copying over the AMI volume, essentially creating your hard drive, and now it's going through the initializing phase. So it's still not running. We're still waiting for it to load. So like I said, about 7 minutes 33 seconds or so, it's going to be ready to access in the cloud. While we're waiting for that to load, let's look at some of the EC2 terminology that you'll need to be successful. Some of these we've already talked about. For instance, a virtual server. If you've ever done virtualization outside of the cloud environment, you've probably used a product like VMware or Hyper-V, and you'll create multiple VMs or virtual machines or virtual servers. Well, Amazon calls those instances, whether they are powered on or powered off. There's a misnomer that if the instance is turned off, well, the virtual machine is turned off, it's not an instance anymore. It actually is. These are all considered instance. Oh, we're running now. So I've got an Ubuntu instance and I've got a Windows instance. As a matter of fact, let's name that guy. We'll call him. We'll just call him Windows guy. Save. So we've got our Windows instance there, our Ubuntu instance. One's running, one is not. We've got the AMI that was used to generate those. Now again, those are the machine disk templates. That's your way to create machines in the cloud. You don't have the ability to take a DVD and connect it to the cloud or anything like that, unless there's some third-party way of doing that. But while I'm here, let me also mention, because I was just mentioning virtualization outside of the cloud, if you are using VMware, you can create, for instance, virtual machines out here. They have a product called ESX, which, by the way, you can get a single server instance for, now I'm using Amazon terms, a single server install of VMware ESX for free. And so you can run it in your environment and do all kinds of fun stuff with it. So let's say you wanted to create your own little virtual machine out there in ESX without paying for usage fees or anything like that from Amazon. You can do that all day. And I mean, you can even create things that don't exist in Amazon's AMI library or in the AMI marketplace, which we'll explore momentarily. So let's say you wanted to run, I'll say an Asterisk. Asterisk is a free open source voice over IP system. It's actually pretty fantastic. Maybe there's not an AMI of Asterisk that suits your need. You can create it in VMware ESX, and for free, Amazon will allow you to import it into the cloud and then run it as an AMI in their environment. And they even allow you to export AMIs that, now let me make sure I say this carefully, that you have previously imported. So for instance, if you create that Asterisk ESX server out here and then you import it here, then Amazon will oh yeah, sure, take that all day long. I'll go red. Take that all day long. You can export it for free of charge outside of normal storage use and bandwidth usage and all that, and export it down to the ESX server environment that it started in. Now you might say, well, it seems strange. Why can't I export AMIs of the other stuff? Well, we're going to start getting into some of the cost of Amazon coming up soon, where we'll talk about what you pay for each one of these things. But in the Windows instances, when you spin one up like I just did, I've got my Windows guy instance now, Amazon includes all of the Microsoft licensing in the fees that you pay. So in all the charges that you pay to run that instance in the cloud, part of your hourly rate is a percentage that goes off to Microsoft services. So if they allowed you to export previously built AMIs, it could be a pretty nasty software piracy environment, because people could just start sucking down pre-built Microsoft machines, fully licensed. It wouldn't be good. So it's only the ones that you pre-build that you can export. Let's keep going down this list with probably the most fun one to say: ephemeral storage. Say it with me. Come on. Ephemeral. You know you want to. Ephemeral. Go to your family member or friend and say, do you know what ephemeral storage is? And they'll be like, wow, that sounds complex. Or they might say, well, actually, that's temporary storage in the cloud. That's really what this is. And I think of it like scary storage. When you first start getting used to it, this is storage. So let me define it for you. When you first boot up an AMI, here's kind of what happens behind the scenes. Now this one is not using ephemeral storage. It's using EBS, and that's because I chose to start off with a micro instance, which the default is EBS. I'll explain what EBS is in just a moment. But let me just show you. Let's say I launched another instance and I actually chose a real instance type. Let's say I'm using Ubuntu server and I go beyond the free ones, the little micro guys, and I say I'm going to do a medium size instance and hit continue. You'll see that the default storage for the system is going to be ephemeral. And what that means is when you power down that machine, it's gone. I know, you're like, what do you mean, like gone? I mean, gone. Like it's deleted. The hard drive is toast, and it's back to whatever the AMI. Oh, got to underline that right. AMI was when you first created the instance. Now I know that may be a shock to the system. It was for me when I first got into AWS because I thought, why? You know, like I'm an IT guy. I build servers, and those servers are meant to stay there. I don't build a server to destroy it. Like that's not what I do. But it's getting into the elastic computing mindset. That's the whole value behind this. There's a word there that I'm missing, but essentially you can build your own AMI, right? So AMIs are meant to be, as you start scaling your system well, little workhorses. So think of an AMI that you create. I don't know why I'm drawing a little guy, but this is a web server workhorse, and all of the web servers in your environment are essentially the same thing, right? They're just like I am here to service people that are coming to my webpage and streaming videos or playing music files or whatever your website does. So I can take an AMI, or let me back up and say I can create an AMI that embodies my web server in perfect form. Like it's got all the right files on it for my latest web processing, the right Java applications, the right blah 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 blah. You know, down the road you go, and I can start replicating that same web server instance because all it is a little clone workhorse, right? So when my website, which let's go back to Animoto, right? Animoto reaches a state where they're like, man, we got to scale from 40 instances to 5,000 instances. They didn't have a bunch of little guys running around going like, build the instances, build the instances. What they did was create one beautiful template AMI system that said, this is our web server, or this is our transcoder, which converts video into, you know, whatever else they do behind the scenes. That's their business, right? They've got all these little AMIs that, you know, maybe one of them is a web, one of them is a transcoder. I'll put Xcode behind the scenes. One of them is a database instance, you know, whatever they've got running, that they can take those clone machines, those perfect machines, and spin them up on the fly. Well, what happens is behind the scenes, all these AMIs are stored in this big bucket that I'll call S3, and we're going to come back to that quite a bit later. Some of you know what I'm talking about. So AMI is stored in this big bucket called S3, which is permanent but not extremely speedy storage. And so as you boot up these instances, they're copying the AMI from that S3 storage into ephemeral storage, which, what is that? It's the storage running on the servers. I mean, Amazon has racks and racks and racks and racks and racks of servers, right, that support these instances. Have you ever seen a rack mount server? Let me pull up some images. If you look at any one of these, let me grab my pen. What are those and those and those and those, a lot of those right there? You know, what those are hard disks. There you go, a whole bunch of them right there. These are all hard disk. 1, 2, 3, 4, 5. Probably spliced together in like a RAID kind of setup, RAID 5 or something like that, so it's redundant. You can lose any one of those hard disks and it still survives. Well, Amazon behind the scenes in their cloud has all of these servers with local storage, which they decided to call ephemeral, temporary storage. It copies your AMI there, and it's there while it's running. I mean, you can do whatever you want to it. You can add files, delete files, add functions, services, whatever you want to do on there, but it's all running locally on one of these servers. Well, whenever you turn off that machine, it is removed from the server, scrubbed, so that Amazon can make room on their servers for other people's to run their stuff. Now, you might say, well, my model doesn't embody that. I don't have a bunch of clones that come along and you know, act as web servers or transcoders. So first off, can I say you probably will someday, once you get into the mindset of Amazon Web Services and elastic computing. But what if you don't? Well, a couple things. One is, if something is running in ephemeral storage, you can do snapshots of it. You can take snapshots of that image and then create AMIs from that. So what that tells you is, let's say you started just like I did right here with the close this down. The base Windows instance, Windows 2008 R2, I named it Windows Guy, and then I come in there and I add remote desktop services and Active Directory and blah, 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 all my customizations to it. I can then snapshot that and then take that over to a new AMI that I can name myself. That is now Jeremy's Windows AMI version 1.1, and I've got a spreadsheet somewhere that says my AMI version 1.1 includes da 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 da. So the next time I spin up a new Windows instance, I start from 1.1 and then build more from there and maybe generate AMI 1.2 once I've added upgrades to that. So that's one way that you can make them a little more permanent. The other way is using Elastic Block Store. And can I back up just a second and let you know that until, and I want to say the word recently, but it's been years, but until fairly recently, ephemeral storage was all there was. Amazon released Amazon Web Services and EC2 services as this clone mentality. Like, we're going to create this perfect image, this AMI, and there's a whole bunch of strategies behind that. And when we get into the architecture course, I'll be going through bootstrapping and how to build an AMI the right way and ways of thinking, high available. I mean, I'm just like, bleh, but I started this nugget by saying, I don't even remember what I started saying. Well, if nothing else, right? No, if that's what it is. That's it. We're just going to talk about Amazon services. So I will save a lot of that discussion for later on in the series. But EBS, which you can see right here, this is what I'm using for both my Ubuntu email server and my Windows Guy instance. EBS stands for Elastic Block Store. This is real instance hard disks that are saved. So, first off, they are typically slower than ephemeral storage because they're running. I mean, when you architect a data center, a lot of times you'll have your servers running right here. They have their local hard drives, right? But you can also run device hard drives from big storage blobs out there, which could be a SAN, a storage area network, or sometimes people run them off of a NAS, network attached storage. They're very similar but very different ways of storing, and that's where Elastic Block Store is stored. So when you provision a server, you can say, no, not ephemeral storage. I want it to be Elastic Block Storage. So now the server boots up, but it's actually booting the hard drive, which is stored somewhere else, and that's what they call Elastic Block Stored. Those ones, when you power them off, stay around. Now, I still wouldn't feel warm and fuzzy about not having backups or things like that, because something can happen, and Amazon says, hey, it is your responsibility to back up your devices, and they give you all the tools to do that. But Amazon will say that EBS and the drives associated with it is replicated to more than one system. So for instance, if you have one SAN and your data is stored right here, Amazon will replicate it to one other system. Now, we'll see another storage unit called S3, which I just showed you the bucket for that in a moment, which is, I mean, when you start looking at the reliability of that, it's like 99.999999999. Like you will never lose something from S3 because of the amount of time that Amazon replicates that data between multiple systems. So EBS is replicated between multiple systems. It is striped across redundant hard drives, so there is no single point of failure. But I mean, just like anything, if you prepare for failure, you'll never fail, right? Just like anything, there's a chance that it could fail. And so while it is very reliable, it's even more reliable than running a commodity, server hard drive system, I would still say yes, you want to have backups for the data that are on there. Okay. Last thing that I want to talk about while we're here is the Elastic Compute Unit. Elastic Compute Unit, or ECU, is a measure of EC2 processing power. Right? What Amazon said is, you know what? We've got all of these servers that are in our racks, and they know, as well as you and I do, that processor speeds change a lot. As you replace servers, bigger processors. I mean, you don't want to have systems where somebody runs an AMI and it goes into an instance, right? And is now running on a server, and they're like, oh man, I got a lame server. That's like a 5-year-old server. Whereas someone else is like, woohoo, I got picked for the winning new server. So what Amazon did was scaled all their equipment around this concept of an ECU. Now this is a new term. So when you sign up, matter of fact, let me go back to the Amazon page. When you start an instance and you say, well, here's the kind of machine I want to run. Let's say, it's a Linux instance, and you see this instance type. You hit the drop down, and you notice the small instance has an ECU. A medium has 2 ECUs, 4 ECUs. So you can think of these as saying this is 1 processor, this is 2 processors, 8 processors, 13 processors, 26 processors. I mean, these giant machines as you give it. So all of these are saying, well, you have 26 ECU processors. What are those? There is a lot of documentation on what an ECU is, but if you boil it down, it is a 1.0 to 1.2 gigahertz 2007 Xeon processor. So if you're looking for just a measure of speed, that's the measure we're at. Now, you might say, well, it seems old. I mean, here we are. We're 2013 and beyond. Why are we talking 2007 processors? Well, so are there 2007 processors actually running these servers? No, they're not. Amazon has just scaled it in such a way and provisioned the resources of their servers in such a way that 1 ECU equals 1.0 to 1.2 gigahertz, or speed of your processor unit, so that you can accurately scale your servers according to that. All you got to do is take, well, we'll just go with the worst case scenario, 1.0 gigahertz processor times the number of cores that your instance has. Now, that'll be, we're actually going to talk about that in a second. So let's just say it has 6, and that, I mean, we needed a math problem for that. So that gives you 6 gigahertz total processing power. So you can just look at the requirements of your applications and say, does that meet it? Do we need a larger instance, or can we scale down to a smaller one? Let me use that as a springboard to move into instance types, because the processing power, the ECUs, is just one aspect of an instance that's running. You also have memory, storage, and I/O performance. Now, this is selected when you go into launch an instance. So I'll bring that up and go to continue. I'll just say, whatever I picked, and you choose the instance type right here. You have all of these different options that you are able to go after. Now, each one of these are going to impact what you pay to run that server on a per hour basis. We're going to talk about billing actually, I believe it's the next nugget or the one thereafter. So we've got these instance types that you can choose from, and each one provides like a combination, a combo aspect of memory, processing power, storage, and I/O performance. Now, this is not a mix and match. This is not like, for instance, when you go and order a machine from Dell, where you can customize that machine and add how much memory you want and how much processor you want and all that. What Amazon does is they say, okay, well, we've chosen instance families for you that put together little cocktail mixes of memory, processing power, included storage, and I/O performance that just comes with that family. So it's not amazingly customizable, but it allows Amazon to scale this in a cost-effective way. So when you look at these different instance types, what you're able to see is the essentially CPU units, the cores that are available to you, and then the memory inside of there. So Amazon has actually, there's been so many questions on this, and we will continue to unpack this as we get into some of the billing sections. But Amazon, I'll give you this website right now, has produced a website called awsnow.info. Now, there are a lot of knockoffs of this, meaning people that have done essentially harvesting from Amazon's web pages to create their own little version of this. But this is one of the first Amazon-backed information that gives you essentially info on everything. So you've got the instance types that we're talking about right here. Let me increase that to 25 records per page so we can actually see how many instances you can get and then where they fall. Now notice, you can see that elastic computing, that mindset is really, look at their home right over here. It's kind of like, okay, all these little small instances. Amazon's design, they actually call this horizontal computing. Let me move this down just a little. Horizontal computing is you bring up a whole bunch of smaller minions to create this massive scalable army rather than getting these giant servers that are there. But I'll say recently, very recently, Amazon has started creating some giant servers right there. Like there is a memory optimized family, which, look at that thing, 88 elastic computing units, 88 1.0 processors is their or to 1.2 processors with 244 gigabytes of memory by now. Each one of these things run on an hourly basis. I'm sure that thing is, I don't know, I haven't looked at the pricing as of late, but I would pay for that just to see. I'm going to pay for that just to see it run for an hour. I just want to, I don't know, boot Windows, do something with an 88 ECU powered machine. With, I mean, so you can see just across the board what kind of instances are there, and then you can scroll down into all of the different. I mean, look at that scroll bar. Blah. These are AWS now really gives you a look and feel at all of the different pricing, all from one place. So very, very handy website. I'll reference it again when we get to the actual billing. But the best practice for scaling these computing units is to start small, benchmark it, see how things are looking, watch your processing power, and then scale up if necessary. It's going to benefit you if you can create your application, your cloud-based web services, or whatever you're running from there, to run across a smaller scale instance and a lot of them. It gives you a lot better redundancy capabilities, gives you a lot better scaling, because you can spin these up on the fly. And that's the whole idea of horizontal scaling, is create more instances, which scales infinitely, rather than creating bigger instances. This is known as vertical scaling, to where instead of saying, well, I need more of them and a lot of them, I do vertical scaling, which is I just add a ton of processing power and memory to my one big old box or two big old boxes that do all the processing. Well, that's fine, and there are cases where you may need that, but you're always going to hit the ceiling here, because you're going to reach. I mean, what do you do when you get to the 8x large instance type with 88 ECU and 60, or let's go with this guy, memory, 244 gigs of memory? I mean, what do you do when you hit the max in your application's like, I need more? I can't fathom an application that does that, but you can't go any further. You've hit the ceiling, which is why that horizontal scaling is much better. Now, notice there's also one more I'll add on to this, a cluster GPU. That's graphics processing. So there are applications, especially like video transcoding, things like that, where you just need really high-end video processor, which just have a completely different architecture than a normal CPU. So you may have a high CPU, which benefits you nothing compared to a cluster GPU, graphics processing unit, which really kicks out a lot more video rendering than you'd be able to do even if you had a whole high CPU instance. The last thing I want to talk about in terms of instance performance is the I/O rating. Everything else is quantifiable, meaning memory and CPU resources. You can say, okay, there's 88 ECU or 5 gigs of memory or what, and you can say, okay, those are quantifiable. It's like taking a big old cake and saying, you get that piece of the pie on that server, because you can carve that out with virtualization. When it comes to I/O, that is talking about a shared resource access. Now, I/O means typically what people will talk about on disk access. So when you save something to a hard drive, what you have to be aware of, and think this through, is Amazon will provision the I/O in such a way that the instance types are given equal share. So let me put that into a little more quantifiable terms. We talked about instance types like micro, small, medium, large, extra large, all this kind of stuff. These cocktails of resources put together. If somebody had let's just say a server, and it was all medium instances. Let's say there's three medium instances running on that server. That was a horrible little diagram there. Let me do that. No. How do you? Let's say there are two. How do you divide a pie 3 ways equally? Right? Am I just like hitting the wall here on? Isn't it? Right. That no. Okay, there are 2 instances running on that server, and they're both medium. What Amazon will do is naturally provision I/O access and access to the shared resources equally between them. If you add, let's go this way, 2 more medium instances to that box, then they will be provisioned 4 ways, to where the access to the shared resources, the network and the disk, are provisioned in 4 ways between those medium instances. However, when you start dropping down in instances, let's say somebody starts adding these little micro instances to that server. Well, what it's going to do is, and now this is where my art breaks down. It's not just going to, it's not like that medium instance just got shafted. It's going to equally proportion take away from all the other medium instances, but then start carving up the micro instances down there. So the micro instances will be kind of left out in the sense that they are going to be competing against all the medium instances that are there. So these guys are doing heavy read writes to the disk that's shared, the disk resources that are shared among everybody. Well, these micro instances might just be kind of stuck. They may just have slow I/O because they're the low ones on the totem pole. So when you see the ratings on the ECUs, or not ECUs, but on the instances, you will actually see them say low, moderate, high, and very high accesses to I/O levels. Now, those you can't quantify, though. You can't say, very high gives me, equals this many IOPS or anything like that. Now, there are things that Amazon has come out with since the early days, and number one is EBS provisioned IOPS, to where you can actually pay for a certain level of I/O that you can receive from that, and that's something that you can reserve. You can pay extra for your EBS volumes in that case. They also have very high I/O levels, which are supported by solid-state disks. SSD or solid-state, flash-based memory disks are at a premium. They're very high priced, but they're very fast on access. So you can also choose to go with an instance that uses SSD storage. You're going to pay more for it, but you're going to get a little more measurable and guaranteed level of disk I/O access. Something you can do that is, I would say, very cost effective. This has become a little older of a tip now, now that the provisioned IOPS for EBS volumes and SSD have been released. However, there are still a lot of people that do it, and that is by using RAID 0. So within Windows or within Linux, you can go into the operating system itself and start doing something called disk striping, or technically called RAID 0. It's where you take a bunch of disks and start striping data between them. So let's say you save a 3 megabyte file. And I'll just do this for the math. What this can do, and it's not going to be exactly like this, but it can stripe and put 1 megabyte on that disk, 1 megabyte on that disk, 1 megabyte on that disk. In essence, and since the 3 disks can read and write all at the same time, you can actually get, it doesn't technically work out this way, but think of it this way, as double, triple, quadruple the performance by striping all those together. Now, there is a risk in RAID 0, and that is if you lose any one of those disks, like this one dies, goes up in flames, you lose all the data on those disks that are combined together. But number one, with Amazon's high redundancy systems, it's very rare that you would ever lose a disk in that volume. Not to say that you wouldn't, or that backups shouldn't be a regular practice with you, but it's very rare. But second off, I forgot what I was going to say second off. What was I going to say? I'm not too sure, but I know it wasn't important. So you can go into your operating system, and the way that you would do it is create an instance. So here's your, Windows server, and start attaching multiple EBS volumes, EBS. And we're going to have a whole section just on storage where we'll talk all about EBS. By the way, you can attach so I can take a drive from an instance, move it to another instance, and attach it over there. It's totally flexible, but you can just start creating EBS volumes. Maybe they're 10 gigabytes a piece, and you add 8 of them. And I think there's a formula somewhere around 8 or 9. You just start reaching the maximum of what a network is capable of doing, so you don't really gain much benefit when you start striping beyond. I can't remember if it's 8 or 9 or it's a certain level of drives. But you can just start adding these little 10 gig drives and then combine them together in RAID 0, and so it adds all the space together. So 10 plus 10 plus 10, and then you gain the performance of going and all these drives running at the same time. So that's a quick, I would say, cheaper way of getting pretty fast access to your data if you need a higher performance drive and you don't want to use the provisioned IOPS or the solid state disks. I'd love to jam in more, but I just can't squish it all into one nugget. So let's put a dividing line there. We will continue on with our EC2 journey, get into pricing, get into more information all about how EC2 works. For now, we have seen what EC2 is all about: Elastic Compute Cloud, EC2, running virtual servers in the cloud. We have seen the terminology that goes into it, things like AMI, things like instances, EBS, ephemeral storage, elastic compute units. And then we start exploring the instance types, seeing the different levels of servers that we could provision in the cloud. I hope this has been informative for you, and I'd like to thank you for viewing.